One of the first concepts in section 6.4 comes across in this problem where we're asked to find the least common multiple of 2x plus 8 and 3x plus 12. Now the correct way to approach this problem is to take the first expression and factor it. So in factored form that would become 2 and the other factor would be 2x plus 4. In factored form this would be 3 and the other factor would be 3x plus 4. If I want to find the LCM, which is the least common multiple, remember first of all that I'm not looking for greatest common factor. I'm not looking for GCF, I'm looking for LCM. The multiples of 2 are things like 2, 4, 6, 8, and so on. The multiples of 3 are 3, 6, 9, 12, and so on. What's the smallest multiple that they have in common? That would be 6. Another way to say it, the smallest number that 2 and 3 are both, factors of that they would go into would be 6. Now, when it comes to algebraic expressions, x plus 4 here is raised to the first power, x plus 4 here is raised to the first power. You're going to put it in the LCM, the greatest number of the highest power you see it to in any single factorization. And in this case, the highest power is just 1. So my LCM would be 6 times the quantity x plus 4. Let me make a point. If this had been x plus 4 and this had been x plus 4 squared, then here it would have been x plus 4 quantity squared. You bring the highest power when it's a variable expression from any time you see it in either factorization. But in this case, that is my answer. Okay, solve and check. My equation is 7 over 5v plus 1 over v equals 1. The way I tell my students to check is to start off by stating what I call RVs. My term RV stands for restricted value, and that would be what v cannot equal. What would make this denominator 0? In other words, what would I have to plug in for v so that 5 times v would become 0? Well, the answer is 0. What would I have to plug into this denominator so it became 0? 0. So v cannot equal 0. Because remember, at all cost, you have to avoid a denominator ever becoming 0. Okay? So that's my restricted value. If I'm solving this equation, I want to get rid of fractions. I'm going to multiply through by the LCD, which in this case would be 5v. So bam, bam, and bam. See how I did that 3 times? In the first one, the 5v's cancel, leaving me with 7. In the next multiplication, the v's cancel. 5 times 1 is 5, and 1 times 5v is 5v. We get 12 is equal to 5v, and I divide by 5. Therefore, v is equal to 12/5. Now notice the problem said check. What it really needs you to do is not actually go back and plug in a 12/5. Just check that your answer is not one of the restricted values. Well, this is obviously not 0, therefore it's accepted. Okay? If you saw the movie, I think it was called Meet the Parents, where the prospective father-in-law kept saying, "You're in my circle of trust." Okay? 12/5 is in my circle of trust because it's not a restricted value. And we're done.